In this video, we're going to work through our first example of how to generate a grouped frequency distribution. And so as we start, let's remember that the how many intervals we have is going to be dependent on our first step in determining I, the width of the interval. And the width of the interval will capture scores within those predefined limits. So the first step to determine I is we go to the raw data and we use the range, and that's basically the difference between the highest score, individual score, and the lowest individual score. So as an example, let's imagine in a fitness facility, the heart rates of people that exercise, particularly 1,000 people, and it varied from 90 to 160 beats per minute. And so our first step into trying to get an understanding of how many people had heart rates within that range and how that distributed, we have to first determine how wide that interval should be. And recall that the interval width should be an odd value. So we start with a range, we start with a width of 3. So that's just something that is a convenient number to start with. So we compute the range, which is the highest value that was observed, 160, and we subtract the lowest value that was observed from the raw data, which is 90. Okay, that equals 70. We then divide that by I, in this case, which is 3, and that gives us 23.33 intervals or groupings of data. And recall, our goal is to end up with somewhere between 10 and 12 different 12 unique intervals. So 23 is too high here. So then we move to the next odd value up, I equals 5. We have the same range. Okay, so that hasn't changed, so it's still 160, subtract 90, but this time we divide it by 5, and that will give us 14 intervals. So this is much better. It's still a little bit higher than the 10 to 12 goal that we're shooting for. So we'll take the step one more time, and so we're going to widen the interval. We've widened it from 3 beats per minute to a range of 5 to now 7. Same range, 160 subtract 90 equals 70. Now we divide it by 7, and we have 10 intervals, and that aligns with our recommended number of intervals to have. And so this is the one we want to go with. Okay, so sometimes this can often be up to interpretation on the individual researcher, but for consistency in this course, let's go for 10 to 12, and that's what we're going to shoot for when we make our grouped frequency distributions. Although be aware that it's not uncommon to see sometimes a higher number of intervals. So here we see our part of our grouped frequency distribution. So this is not the entire table, but I'm just going to highlight some points here in terms of how to start populating the frequency distribution table. So for the midpoint, so we're going to have a midpoint, and the midpoint value is that representation for the interval. Remembering that the interval width here is going to be a 7. And so 7 values will fall within the apparent limits. And then the real limits will set a little bit later when we add and subtract 0.5 on the high end for the addition and subtract 0.5 on the low end. So, and also recall what our range is. So the lowest observed value is 90, the highest observed value is 160 with an interval width of 7. So how do we start this? How do we find that first midpoint value? Well, the midpoint value has to be a multiple of the interval width. So if we multiply 7 by 10, that's a 70. But we don't have any heart rates even close to 70. Our lowest value is 90. So 7 times 11, that's the next multiple up of 7, is going to give us 77, still nowhere close to that lowest value of 90. And we continue until we land with 7 times 13, which is 91. And 91, it's not the exact same value as 90, but it's very close to 90. And so we know that since the interval width is 7, we know that 90 is going to be captured within that interval. So we take the 91 and we start our table at the very bottom on the midpoint value. So that becomes our new midpoint. We then move up multiples of 7 until we get to the highest point, which is 161. Recall our highest heart rate that was observed was 165, which will be captured in this interval. And so 91 plus 7 is 98, which is the next midpoint. 98 plus 7 is 105, which is the next midpoint. And we continue to move upwards until we get to the last midpoint that captures the highest observed value from the raw data. And we then set our apparent limits, as you can see here. And so we calculate the apparent limits from the midpoint. So the equation to do this is we take the midpoint, 91, and we add and subtract. So we'll add for the upper limit for the midpoint, which is the interval width of 7 minus 1. It's going to be a 6 divided by 2, which is 3. So 91 plus 3 gives us a high of 94. So we repeat that and we subtract 3 from 91 to give us the lower limit, which is 88. And then we repeat the process for the next midpoint, and we end up with a range of 95 to 101, 102 to 108. We then move on to compute the real limits around the apparent limits. So in doing so, we basically add and subtract 0.5 from the high and the low end respectively. So we add 0.5 to the high point on the apparent limit to a 94.5, and we subtract 0.5 from the low end to produce an 87.5, and we repeat the exact same process for the next row, and all the rows until we get to the end. So this ends our this video that steps through the process in generating a grouped frequency distribution table. And the next video, we're going to work through another example of doing the same thing.